Hi, everybody. Hope you're having a fine Saturday. I'm happy that the day's almost done. So that's the good news for me. Anyhow, we're going to talk about amateur radio in space. We are going to talk about the ISS and making contact with astronauts and that was. But there's a little more to it. I thought that there would be a little more meat to kind of talk about just amateur radio that happens in space already. So just keep that in mind as we go through this. I'm looking at the chat over here on the side, so if you have any questions, go ahead and just drop them in. If I see them, I will try to respond as we go. Or if you want to wait, you can hold them until the end. So either will work for me. All right, so let's dive in. So this is me, obviously a younger version of me, but that's all right. A lot less gray hair. You look now, it looks like my younger brother. But my name is Randy Hall. I am a high school teacher in Sonoma County. I teach video and digital media to high schoolers, and I really enjoy that job a lot. And the other thing I do is I play with radio. And so I'm an amateur radio operator, or ham, as they would be described. And one of the things I love to do is communicate. That is kind of the visual medium that I use. Involves a lot of being able to express yourself and communicate with others. And being a teacher also does that too. And I happen to be a pretty decent cook. I thought that I needed 4 things on the page, so I just said I think I'm a pretty decent cook as well. In fact, we're making fish tonight, so there you go. All right, so amateur radio in space. What does this even mean? Let's dive into some of that. So when you think about what's in space above the Earth, there's a lot of stuff up there. I don't remember the actual number of objects in orbit, but it's a lot. I mean, there's actually a catalog, and there are government entities that are basically tasked with tracking every single piece of it. And so, yeah, there's definitely a lot of stuff up there, but it's, and a lot of it is satellites that are actually usable and useful to us down here on the surface of the Earth. There are communication satellites, weather satellites, obviously military, the GPS that you might have in your phone or in your car uses satellites that are floating up in space to locate you on the surface of the Earth. And they come in 3 different kind of varieties of satellites. You have low Earth orbit, okay, and these are ones that are closer to the Earth's surface by comparison. And these pass by the Earth, or these orbit around the Earth less than at a shorter period than 24 hours. So you'll see multiple times a day they're going to arrive and pass by, or they're going to orbit multiple times in a single day. Then you have high Earth orbit, which is actually where the satellites go slower than, so it's like it would be more than a day between each time you see it. So it's slower than low Earth orbit. So low Earth orbit is much faster, much closer to the Earth, and the high Earth orbit is relatively slower by the way that we perceive it here on the ground. And then you also have geostationary satellites, and those are like television broadcast, commercial broadcast stuff, as well as weather satellites. There are some geostationary weather satellites and so on. And amateur satellites are up there too. Almost all of them are low Earth orbit. They're often built by universities for research, but they have had ones that have been built by high schoolers. And many of these are sponsored by AMSAT, which is a company called it's the Radio Amateur Satellite Corporation, but the short phrase is called AMSAT. And they are responsible for raising money for and helping to facilitate getting those satellites built and then into orbit. And then finally, there's even a space station, right? I mean, there's people up floating above the Earth 24 hours a day, and they are up there, and wouldn't it be cool to talk to them? So when an astronaut is also a ham like me, some exciting things can happen. And that is this thing right here. So we're going to talk, I'm going to present this video to you really quick, and then we'll get back to this. So this is an astronaut up in the International Space Station.
NA1SS, this is N2SJ, over.
NA2SJ from NA1SS for scheduled contact.
Hi everyone, I'm Tim Peake and welcome aboard the International Space Station, where we're orbiting Earth 16 times every day. One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now these are events that are planned by ARRIS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering and mathematics. Now this is the equipment here in the Columbus laboratory, which consists of a handheld radio, a headset, and we also have a ham video unit. Now as the International Space Station orbits above your location, a radio link is established between the ISS and your school. Now because we're travelling at nearly 18,000 miles per hour, which is an incredible 25 times the speed of sound, we usually get about 9 or 10 minutes of good radio contact before losing the signal. So about 5 minutes before the scheduled start time of the contact, I come into the Columbus laboratory and configure the radio so that I'm on the correct channel. And sometimes I'll set up the ham video too. Just before the predicted time, I'll begin to start calling the school using the standard amateur radio calling techniques. For example, if the call sign of your school was GB4 Fun, I would say Golf Bravo 4, Foxtrot Uniform November. This is Golf Bravo 1 Sierra Sierra, listening and standing by. Now at your school, the radio operator will be listening for my call, but may also transmit and try to call me as well. You'll probably have a much more powerful transmitter on the ground than we have up here on board, so I'm likely to hear you before you hear me. Then, once we can hear each other, then comes the best bit, which is actually talking to the students and answering the questions. Once I've answered all the questions, we use the remaining time to say goodbye to each other and end the connection. I'll then spend a few minutes configuring the radio back into a rebroadcast mode, and then I'll go back to my day job, which is of course doing science on board the International Space Station. ARRIS is a brilliant opportunity for astronauts to talk to school pupils. It's really rewarding to hear how excited the students are when they're talking to somebody up here in space. And it's a true privilege to be able to inspire our next generation of scientists and engineers through amateur radio.
Okay, so, and then there's more information obviously with these different organizations. So let's go ahead and, oops, going to actually skip this part. There we go, okay. And somebody had their hand up? I mean, I've been answering questions in the chat, so I can take questions here or in the chat. So if you, so let me see. I will have to pull up the participant list here really quick to be able to see who's got their hand up. So
Mina has her hand. I'm sorry, Randy. Mina has her hand up.
Okay, Mina, why don't you go ahead with your question?
Do you need a specific degree to be able to do like ham, or can you volunteer and help?
To actually, it's that's a great question. So in order to get an amateur radio license, you do have to study a bit, but you don't need a degree. It's not something you go to college for. It's just a series of technical questions, and some of them are not as technical as others. You know, there's really not. It's not difficult. I wouldn't say it's difficult to get licensed to do amateur radio stuff. It is, but it does take some study. So if you and if you are technically motivated, or if you are interested in electronics or electricity and electromagnetic waves and things of that kind of those sorts of scientific subjects, you might know quite a lot of what you need to know in order to be able to be licensed. And the best part is that there's really no, I don't think there's actually a minimum age. So any of you who have any ability and interest and aptitude to go after getting licensed as an amateur, I'm certain that you could. Thomas, you are the other person who I see has their hand up. Why don't you go ahead?
My brother's asking me if you could let him in because he's been waiting in the waiting room for a while.
Oh, well, I think the host will have to take care of that one, but that's good.
We will look at that. I don't see anybody in the waiting room, so I'm not sure. We're trying to work on that problem there.
Oh, one last thing. I did actually just send him an email with the link. I was going to copy and paste it to you, but you'll probably have a hard time copying and pasting it out of the chat since that's not really a feature. Bye.
So, okay, so I see Ankin, is that your name?
Yeah. So
Okay,
my
go ahead.
question is that, so when we have ARRIS, is that how does ARRIS connect to the space station? Do they talk to NASA and then NASA connects to the space station, or or ARRIS just talks to the space station?
Ooh, very good question. Actually, it is that when they do contacts with the space station using amateur radio, it's direct. They're going directly using, there's actually amateur radio equipment that is tuned to those frequencies, amateur frequencies that, so go ahead.
Yeah, what my question was is that instead of when you're talking, is that when you're trying to set up the time to talk with the International Space Station, do they tell NASA or would ARRIS tell the space station directly?
Okay, gotcha. Now I understand your question. Thank you for that. And we actually will talk briefly about that, but realistically, it is a process where where a school would arrange to, they would request to schedule it. It does end up going through NASA, so you would work with NASA and with and AMSAT to a lesser degree. They're not as involved in that particular aspect of it, but ARRIS is a part of that. So there's multiple different kind of groups of people that would come together to find the right time and the right opportunity for any particular school to be able to have a direct conversation with astronauts using ARRIS. Thank you for that. Let's see, Connor, your hand has been up. Actually, yeah, go ahead, Connor, and then I think it'll be Lohith after that. So, Connor, what's your question?
How far can the amateur radio reach?
So, yeah, how far? Oh, you asked that one in the text chat as well. So the technically. The radio frequencies will just keep on going. I mean, once radio actually travels at the speed of light. Okay, so it's when you transmit, you're actually transmitting out at this almost instantaneously. It depending on your antenna, that will indicate how much energy is being kind of sent in the right direction. So, how far it reaches is there's a lot of different variables that play into that. I would say that, the space station is, how many kilometers above the Earth is it? It's quite a few. But you can, using a relatively, modest radio. You don't need a really high-powered, gigantic radio to do this. You could directly reach the International Space Station. So I'm gonna move forward in just a second. I want to get a couple more questions answered. So Lohith, you had a question?
Yeah. The question is, the Earth, the Earth, but all the planets stay in orbit, right?
I'm not sure I followed. Go ahead and try again.
Like all the planets are in orbit, so are the moon. All the moons are in orbit. Like Earth has a moon, and then Neptune and Saturn, and they all have certain number of other moons. So are they all in like orbit, or they just float around the space?
Okay, so I think what you're asking is around other planets, are there moons that are there are moons outside of those planets, and are they orbiting? The answer is yes. They orbit at different times and at different distances from those planets. Ours does its thing. Our moon does its thing for us. But yeah, I was kind of like, wow, that's definitely an interesting question. Last one from this one, and then I'll answer a couple from the chat, and then we'll move on. So I believe Hannah, you've been waiting a bit, so why don't you give me your question? I don't hear Hannah. Oh dear. Okay, well, we'll come back to that. So actually, Hannah, you had actually asked in the text chat. It says, "Look weird when tomatoes were in outer space. Why is the reason?" So, because microgravity, right? There's not a lot of gravity on the International Space Station. You do have a tiny bit because you are still within the realm of the Earth. The Earth has a pretty strong gravitational field. And so you have a tiny, tiny bit. But when you build, usually plants are used to just growing upward toward the sun. Well, what do you do when there's no up? And so, yeah, things can look a lot different. Then also, so next one is from Dan. This will be the last one, and then we're going to move on, and then I'll take more questions in a little bit. We have to go through a school. The general public can't talk to astronauts. Well, we talk a little bit about that a little bit later. You can actually occasionally directly talk to astronauts on the International Space Station, but it's kind of like winning the lottery. It's not very often. Okay, so let's keep moving forward because there's more to cover here. So, so I wanted to really just say that it is fun to talk to astronauts. So if you ever have the opportunity and you can schedule it through your school, I strongly encourage you guys to ask and see if you can get that arranged, because you can ask. I mean, like the questions you're asking me would be brilliantly good questions for an astronaut to answer because they're going to have much more direct knowledge of it than I will. So asking someone who's been living in space about their experience and what they miss about the Earth or what it's like to live in this microgravity environment. And then, you have to also understand that these astronauts were just like you guys. They were kids once that were just curious about the world around them and what lies beyond the boundaries of our planet. That is literally what you guys are doing when you're thinking in these things. So astronauts were kids like you at one point. And so this is a job possibility for you. Keep that in mind. So I think it's pretty exciting personally. I never wanted to be an astronaut, but that doesn't mean I'm not excited for you guys. All right. So here's the bad news. Right now, the International Space Station, the radios for ARRIS, one of them is not working. And it was the one that they just installed last year. And so it's a little bit of a bummer, but so there's they call it the interoperable radio system, and it was put up in the Columbus module, and that was the one that they primarily used to do their contacts with students and schools. Currently, it's being fixed. They don't have a date when they're planning that, but I will say that. Even though that radio is not working and there's been this pandemic for a year now, contacts with schools are still being done, and they're being done using the other radio. There are two actually installed. And so they're using the other radio installation for these contacts. And even though schools have suffered closures, ARRIS, the organization that puts that together, continues to help facilitate these school contacts through what they're calling a virtual multi-point telebridge. Now, that's just a bunch of words, but what that really means is it allows you guys to be at home or in a small group, classroom situation or at your house and be able to communicate and ask the questions that you've prepared in order to get your answers. So Ooh, these are all more good questions are coming in on the chat, so I'll keep those in mind. All right. So now, when time comes to try and put together an event with ARRIS and talking to astronauts, a lot of schools are going through this process. So there's a lot of competition in some ways, but it's also there's just a lot of schools are interested in this program. And so it can take weeks and even sometimes months of preparation. So, you might go away for the summer and come back and still be waiting on when that ISS contact would be happening. Then there's different methods that you can use to contact the International Space Station, which speaks to something I had mentioned earlier, that you can directly contact the International Space Station if they are receiving and ready for that, where you would be able to talk directly to an astronaut from a radio on the ground. Most of the time they use what's called a telebridge, where they'll pick a time when the space station is passing high overhead of a particular location, and they'll have an amateur radio operator at that location make the connection over the radio to the space station, and then they'll run it over a phone line to the school, so that way you guys have the experience of a live conversation with the astronaut without necessarily the technical glitches that can often happen. So these ground stations are very, very they're well qualified, they're very reliable, and so it can definitely set up an environment or it sets up the opportunity for a really, really clean and complete contact with the space station. Then other questions that you have to ask are like, when will the ISS pass overhead? So you have to, because like I said, it's like it's orbiting the Earth. It passes over every spot 5 times a day. The time of day might not be favorable from one week to the next. So it might not be passing overhead during school time, or it might be in the middle of the night. And so how do you deal with that? And then even when it is passing directly overhead, that's for a maximum of 10 minutes. 10 minutes is it. From the time you can start talking to them to the time that they disappear past the horizon. So it's pretty fast and furious when you get into that. So the reminder that ISS passes over or near a spot on the Earth between 4 and 6 times a day. And so how might you get started talking to amateur satellites, including the ISS? Well, let's talk about how you would find out where the ISS is located. So there are tools here. So some of these are apps or software that you can put on a Windows computer, a Mac or Linux, or your mobile devices. And even with the site Heavens Above, it runs in a browser. So even a Chromebook could do this. It's all possible to track where different objects in space are located if you are interested in knowing where they are. So let me take a couple more questions from the chat because these are really good. How long does it take for speech to arrive from Earth to the ISS? It's nearly instantaneous because it's not that far. And as I said, radio travels really, really fast. It travels at the speed of light. So radio waves travel as fast as light. And so that's really fast. And it will... It can, it would feel instantaneous. It would not feel, you might notice a tiny delay, but it would be minuscule compared to the delay of the actual radio equipment that is turning it into audio, or the radio equipment on the space station or on the satellite that is actually repeating that radio signal to a different frequency for somebody else to hear. So will there be a delay from the ISS to connect to the school? Well, I'm not sure what you mean by delay there. And I'm not, so I think in that respect, I would say that it would be negligible. I mean, like less than a second. So I don't know that the delay would be particularly big. If you were doing a direct contact, it would be instantaneous, basically. If you're doing the telebridge, it's because then you're using the phone network that's not a real-time network. That's not actually like radio, believe it or not. It's not like this either. It's like this is definitely not radio, what we're doing right here. What you're hearing from me has been processed using all sorts of digital stuff, and it's taken time to get from my microphone over the internet to your speakers and into your ears. So there's a lot of delay there, whereas in radio, that transmission from one point to another is like that. It's really fast. And then one more question here in the chat, and then we'll move on. With COVID-19, how are people on the space station? How are people on the space station without catching it? Well, I mean, the good news, I guess, with COVID-19 is that there's not a whole lot of kind of community exposure. If COVID-19 were to get to the space station, it would. I mean, all of them would get it. The air is so recirculated in there that that's a very curious question. That would be a great question to ask an astronaut, by the way. And there was an earlier one actually up here that talks about what makes the radio, the ARRIS not work. Debris hitting them. They don't know. They have gone and they've done spacewalks to observe and see what the problem is on the outside, if it's an antenna problem or if it is a radio problem. They've done some initial stuff. Yeah. And so Kathy's mentioning that astronauts do quarantine for many days and weeks prior to going up before any kind of space travel. And, they are in isolation for quite a while. Yeah, the astronauts that are up there have been there for at least the last year. Okay, so let's keep moving. Why is the Earth round? Boy, that's a much longer question. All right, I'm going to move forward. So the other thing, this is a little bit wonkish and lots of numbers here, but I wanted to talk about the idea that sometimes the space station passes right overhead, and sometimes the space station passes like barely off on the horizon. And here's two examples of that. So the images here show here's the path of the ISS, and it's basically just passing the Oregon border. It's actually passing over the southern Oregon border with California, but that's actually close enough that we would basically just barely see it on the horizon, over on the northern horizon. And depending on what buildings or mountains or other things are in the way, might affect whether you're able to actually even contact them. And then this one here, the second one down here, is actually an overhead pass that is, I think, not listed here. This one's actually from March 15th. So in a couple of days, on Monday, it's actually going to pass almost directly overhead. And so this pass right here, I think, is slated to be like 8 minutes long. So this one here, the window to contact the space station is about 2 minutes. So when they're off to the side, you see that how this orbital line intersects the circle that surrounds your location, which this is where I am. How that line intersects that circle tells you that distance from where from the beginning of the red circle to the end is is how long that they're in line of sight, or that they have, that you can acquire a signal from them. So you can see in here that yes, I live in the USA. I live in California. I'm talking to you from my garage, where I speak to my students 5 days a week. So there you go. So yes, today there are 6 different times that the ISS are passing by the Earth, or passing by my location. And let me get back to that. Sorry about that. And the trouble is that it's not right now. Right now it's passing over when the ISS is getting. It's passing over the Pacific Ocean, and later today it will start passing over Northern California again. So about 8:30 p.m. is when we will see the ISS passing by here again. It'll be passing by on the southwest, and then 10 p.m. will be just a little. Is actually going to be a little bit past that on to the north, and then at 11:44. it'll be on the northern northeastern end of the horizon from where I am located, and that's part of the the fun of figuring this out. So I actually live in Sonoma County, in the Santa Rosa area. So that's where I'm from, and I've been living here for a while. So I'm not. I'm not from somewhere else in the country. I'm from here. So, and I believe most of you are too, I believe, but that's okay. All right. Cool. All right. Great questions. Thank you all for that. Let's keep going. So the ground track, so these ground tracks are actually available on this site right here. It's called heavensabove.com. So if you look at where we are, this is about where I'm located, Santa Rosa. And I will update that. And then what it can tell you is it'll tell you where the ISS is currently located. And so actually right now you can see that it's passing over the North Atlantic. So here's the US right here, and here's Europe over on the right-hand side. And the ISS is actually passing across the North Atlantic, and it's going to be heading over Europe and then down past the Middle East and into and then toward the Indian Ocean and Australia. So there's a lot of interesting pieces of that. The other parts of this that are interesting is that for any particular one of these passes, if I'm going to show you, I'll show you some of these from this list here. The next good pass is going to be Monday on the 15th. It's going to pass overhead about 85 degrees overhead. And this is what it would look like if you looked straight up. So this is like the night sky at 4 in the morning, starting at 4:46 and then ending at about 4:56. So it's almost 10 minutes of contact with the space station passing way overhead. And notice that it starts really slow. So at 4:46, it's over here on the horizon. 4:47, it's a little bit above. 4:48, that 1 minute, it's moved a lot further. 4:49, it's moved even further. By 4:50, it's moved so it's moving really fast at that point because it's actually passing right overhead at top speed. So you'll notice that, the idea of tracking a satellite becomes kind of interesting when you have it pass right overhead because it's moving super fast. But yeah, we can look at other things like this is the ground track where it would actually be passing by. And there's Santa Rosa where that black dot is, and there's where the path that the International Space Station would take. So yeah, there's a lot of really cool stuff, and it's all available to you. You guys can play with this. The other thing you can do is there's more than just the International Space Station out there. There are lots of amateur amateur satellites that you can be listening to or make contact with, and not all of them have astronauts on it. I get that. But you can find out which are working, including the ISS, by visiting this page right here, which is AMSAT. As remember, I mentioned AMSAT. They have a web page that you can go to see which satellites are working. And so you can see that there, and it's all done in kind of this table format. And because we're still in March 13th, we're not quite to the 14th yet. That's why this day is not filled in. But you'll see that there are quite a few, international, or there's quite a few different satellites up there that amateur. There we go. All right, so back where we were, right? So this is, let me bring the chat back up so that I can see what you guys are saying. And thanks for coming back. Okay, so I was showing you that you can check on which satellites were working, and so there's this site here. All of these links will be made available to you if you want to research it further. So somebody had asked earlier about contacting the space station yourself, right? If you have the radio and the means, it can sometimes happen. It is like winning the lottery in a lot of ways. So it's not automatic. Oh, let me switch my camera back to a more default view. There we go. You can actually contact it. And when they do fix the ARRIS, the interoperable radio system that was not working, you'll be able to go ahead and be able to use what they call a crossband repeater, where you would transmit up at one frequency and then the space station would retransmit your audio back down to Earth. And so it's like you're being transmitted from the space station. And that's kind of fun and cool too, where you're actually able to, and if somebody else on the ground can hear you, they can transmit back, and you can carry on a conversation that spans a long distance. Where, but at the same time, remember, the pass overhead is at maximum 10 minutes. So you really, generally speaking, when you're talking on a satellite, you go really fast. And if you're lucky, you're able to do it with a small handheld with an external antenna. A handheld like this is a handheld radio. Okay, walkie-talkies, right? So here are some pictures of kids communicating with satellites using amateur radios. So these are, you have, somebody's got one strapped around their waist, and using a wooden pole with these different metallic elements strapped to it. This person here has a small transmitter, a small radio clipped to their belt. They're wearing a headset so that they can listen and talk, and they have that handheld antenna. So these are not particularly challenging things to use. There's a lot more to it. Okay, so there's dozens of satellites in orbit that you can reach with this, with repeaters or transponders. And on a good day, you could go from one satellite to another in relatively short times. If they're passing by in just the right order, and that does happen. I mean, it's not impossible. But the cautionary tale is that it can become a really fun thing to do that becomes addictive. You will be like, oh, I want to do that again, because the first time you talk on a satellite and you hear somebody talk back to you from that satellite, that's actually like, dang, that person's all that far away, and I'm just using an object that's floating in space. So how to get to this point of being able to talk to satellites is you can go out and buy an antenna, obviously, spend, $100, $200, however, as much money as you got, to be able to send your radio signal up to a satellite, or you can build one, and it's almost nothing. So the Instructable that I have, that I linked here, is actually made from PVC and a tape measure. So PVC pipe like you would use for irrigating sprinkler systems in your front yard, or for crop irrigation, stuff like that, and a measuring tape like you'd use to just measure things in your house. So yeah, those things are available to you. Listening also can be relatively cheap. There are these very small devices called SDRs. This particular one is called an RTL SDR. That is it's a very inexpensive little kit that you can use to set up a receiver to receive radio signals. And so this kit that I'm showing here is about $35. So it's like, I know that not everybody's got $35 burning a hole in their pocket, but then again, it's not hundreds and hundreds. So it's like, this is really within reach for a lot of people. And even if that's too precious, you can go cheaper. House free. So if you can get on the internet, if you have a browser and you can go to this website, websdr.org, you actually can select from hundreds of different receivers that are placed all around the world that you can log into with your browser and listen to radio from that. And you can tune it to satellite frequencies and listen to radio satellites that are coming in. So that is one in particular is this one in Utah that does have the ISS frequency already ready for this low Earth orbit setup. So yeah, there's a lot of opportunities. Even if you have no money, you can still play with radio. So if you want to play along, the best way to, especially if you want to make contact with the ISS, you can go through ARRIS. The ARRIS website actually has a lot of information on how to make these contacts. So you can submit a proposal here. There's lots of different resources that you can mess with, and they are doing contacts even now. There's not as many as they normally would, but they are still making contacts with schools even now. So you can submit a proposal for contact, and they'll see what they can figure out for you. And so it's definitely a great opportunity. If you ever have the chance to participate in an ARRIS contact, I really, really strongly encourage you to do so. So that is the talk, and I'm so glad I was able to get it all in before we ran out of time. We only have a few more minutes, but I wanted to no, unfortunately we're not able to talk to astronauts today. I hope that wasn't the that you weren't sold short on that particular aspect of it. There's no scheduled contacts with the space station, and as I showed you, they're not even passing overhead or near anywhere that is within reach until 8 p.m. tonight. So it would be really difficult to have a conversation today with astronauts on this particular call. So I apologize if that was not sold. I don't want to sell you a bill of goods. I wanted you to know that's what we were doing. Any other questions? Ankin, you have your hand up. Do you have another question?
Yeah. So for what was that question? I forgot it. Oopsie.
Oh dear, I'm sorry. Well, if you remember it soon, maybe you can let me know. Any other questions, or? Well, if not, thank you guys very much for being here. And yes, technical glitches aside, yes, absolutely. So if you are interested, I'm going to paste these into the chat. That'll be my final act for you guys. So let me put that in here. So there, that's the, this is the AMSAT status page. This is the tape measure antenna. And this is WebSDR, so you go check that out. And of course, like I said, if you are interested in trying to convince your teachers and your school that you want to do this and you want to contact the amateur or the ISS for a contact with your school, ARRIS.org is where you want to go. All right. Thank you guys so much for being here, and I really appreciate you. This document, actually this presentation, I think I can make available to you right now in the closing moments.